Now listen, we're going to answer the age-old riddle of does microwaving water work? Does microwaving water work? This heating up and boiling water has been a dilemma for millennia. So what you want to do is take water that's either cold, room temperature, or even frozen, and make it warm again. So what I have here is a Hello Kitty cup and a Solo cup. Now the Solo cup is filled with water, it's plastic, and the Hello Kitty cup is glass or technically ceramic. Now if you were to take this water in the Solo cup and pour it in the little kitty cup and put this in the microwave for ever, eventually the water would get stimulated so much and it would heat up the little kitty cup, everything would just burst out. The little kitty cup would shatter and the water, if it hadn't already evaporated, would spill all over the bottom of the microwave. Now how that works is in every microwave, it's literally a microwave radio. That's all it is. In a microwave, it's a 2.4 gigahertz, very powerful, non-filtered microwave radio in the 2.4 gigahertz range. Now, the reason why they use 2.4 gigahertz is because that is the wavelength. That is the wavelength that is required to, it's very, very small, to stimulate a water molecule. H2O, 2 hydrogen atoms, 1 oxygen atom. It's just how it is. It just happens to be 2.4 gigahertz. Very similar to your home internet router, which uses 2.4 gigahertz for the, what is it, the G band or the N band, I forget which. One is 5 gigahertz, one was 2.4. So, yes, microwaving water will work with its limitations. So back in the medieval days, to reheat water, what they would simply do is just take back then they didn't have fancy ceramics and stuff, they had pottery, but pottery will just disintegrate in fire. What they would do is they'd build a fire, okay? And they'd take like a cast iron skillet, or sometimes the wealthy even had bronze, all right? And they would put the water in that container and they would just stick it over the fire. And it would just get to whatever temperature they wanted and they would consume it or do it for whatever purposes they wanted. Now, they didn't understand in the medieval days and then even in the BC times, they didn't understand the mechanisms for how this all worked. They thought there were 3 elements: fire, water, and earth. They're not elements, it's just, So to them it was just like spirits, it's like, you put the water in the vessel, put it over the fire, and you just watch it sizzle. And some even when after Christendom started, they called it the Holy Ghost. To finish your water to where you want it to be, it was the Holy Ghost. Well, time moves on and advances in technology improve, and in the space days, literally that's where microwaving came from, was from space travel. They had to figure out a way for astronauts, after the Apollo missions were going up there and drinking warm temperature, consuming warm temperature meals, I guess you could say. They figured, how can these guys enjoy a nice, hot meal? And weirdly, there was a guy with a chocolate bar and it melted in his pocket and he realized, whatever. So And then they came out with a microwave to put in space for the astronauts. So as I said, 2.4 gigahertz is the magic frequency which boils water. All right. There's even more ways to boil water. Now a fancy way to do it is with nuclear power, with nuclear fission reactions. Now I'm not going to get into all the physics behind nuclear reactions. Basically, it's splitting atoms. For nuclear power, it's uranium atoms. And how you work a nuclear reaction is you have to keep the thing going. It's like a microwave. It has to have power all the time. That microwave has to continually have power. Well, a nuclear reaction has to have a self-sustaining power without going into the stratosphere. So how it does that is it uses water. Water works as the moderator for fission reactions. And water has what's called a negative temperature coefficient of reactivity. All right, I know it's a mouthful, but listen. Water has a negative temperature coefficient of reactivity. What that means is that as water heats up, its coefficient is barn. They call it a barn. It's where neutrons come in and hit the where that gets smaller. So water has a thermalizing, what's called a thermalizing property for fission reactions. Let me back up here. Water has a thermalizing action for nuclear reactions. As an atom splits, it spews off, fission products, and the atom, its mass splits in two, emits all this energy. What also comes out are a lot of neutrons, and these neutrons come out very fast. And water is in the nuclear vessel, the container doing all this heating and working and stuff and boiling water. So as that neutron hits a water molecule, if it hits the hydrogen atom, it slows down, all right? So it bumps into it. It's like bumper cars, okay, just bumper cars. And then it slows down. And as a neutron slows down, its chances of causing another fission reaction, splitting another atom, greatly shoot through the roof, all right? If they're all speeding like at a zillion miles an hour, not literally, but the chances of a fission reaction go way down, okay? That goes way down. Not much work. So you need to slow that neutron down, all right? You listening? So in your water molecules, if they're at a certain temperature, these neutrons love it. They'll find these hydrogen the hydrogen atoms very quickly and bump into them and slow down and cause more reactions. Well, you can regulate that in nuclear reactions. You can regulate that. So as water cools down, as water gets colder, ultimately to freezing, I suppose you could say, it causes its thermalizing properties go way up. The inverse relationship between temperature and reactivity work like that. So as the temperature goes down, the reactivity goes up. As temperature goes up, the reactivity goes down. So hitting these molecules at certain temperatures, there's a sweet spot. It's usually around in non-saturated reactors in below the boiling temperature, it's usually around 400 degrees or so, or maybe a little more. In civilian nuclear reactors, they use saturated steam from the reactor. So they use in fact a lower reactivity coefficient, or in the science field, it's called a barn. That's the size of the relative size of the water molecule to be hit by a neutron. So let's bring this all together. If you want to boil water, if your aim is to boil water, you can use your Hello Kitty cup, or you can use a solo cup. This will melt. This will just shatter. You can also use a skillet and put it over fire. Put your water in a skillet, put it over fire, and watch it boil. Or you can use nuclear reactions. Simply put your water in a nuclear vessel, raise the rods out, and watch your water work. Yes, microwaving water works. Thank you very much. I hope you've enjoyed this video. Have a wonderful day.